Hi, welcome to Scaling Risk Analysis with Reproducible Notebooks. This is an abbreviated version of a talk that I gave at a conference earlier this year, in 2019, at the Society of Information Risk Analysts, SIRICON, in Cincinnati. I'm going to try and start recording more of my talks so that they're available. So why do we care about this? If we can get this slide to change. So this presentation is online at kindlyops.com/019. You can also look at talks.kindlyops.com and find it. You don't have to just watch the video. Also, all these slides are available online. You can see the speaker notes. There's a bunch of links inside here to example notebooks you can actually try out live. And the presentation and all of the materials I reference here are open source. So the presentation was built with Xeringen. So the idea here that I want to convince you of, the thing that I really would like you to do after watching this talk, is to try out a notebook, a computational notebook, whether it's a Jupyter notebook or an RStudio notebook, an R Markdown notebook, but not just open it up and look at it, but to try modifying it, change a calculation, and share it with one other person. That experience of actually collaborating through a notebook. And then a bunch of people that I know, some of you watching this, no doubt, are developing your own products. And so if you're working on a product that does data analysis, that reports on data sets, I have an extra challenge for you. And that is, please, please, please make your product export notebooks. I'm doing this myself with the tools that we're building at KindlyOps. And the reason that's so important is you don't want to lock in your customers' data. Any graphs and reports that you make, you should also be exporting those as notebooks. Make those exportable. It's a challenge. It's kind of a dare. You might be surprised how achievable it is. But one thing is for sure, it unlocks a tremendous amount of trust that the graphs and the things you're doing with the data are actually correct. So the rest of this talk is some stories to try and convince you to do those two things. Try a notebook, make your product export notebooks. So the reason that most people watch talks like this, that go to conferences, the reason people are interested in learning and promoting quantitative risk management techniques is because most of us have felt the pinch of needing to have better conversations about risk. We've experienced the challenge of trying to influence better decisions. So the idea at the very core of this talk is that when you make it really easy for people to try out a new technique, when they can try it without installing new software, when it's comfortable and fluid and easy to change one little parameter, one knob, one number, and see the results change, well then people are much more likely to start using those techniques on their own to get comfortable enough to pick them up and try them. So we're looking for levers that will increase the level of cognitive performance across multiple teams, right? This is not one-on-one stuff, but we want to increase the performance, improve the decisions made by entire departments, entire teams, entire organizations. So techniques and tools that used to be very specialized are now cheaply available to anyone who's interested to try them out. So a good example is the picture on the slide here. Drones. And one of the things that's most amazing about drones is, like, the technology is incredible, but the packaging of the technology into a form that requires minimal operator skill in order to try it out, to actually explore and benefit from the technology, is amazing. And what do you do with drones? The first thing is you play, right? You go fly around and have a little fun with it. As soon as you realize what it can do, you start to realize the practical applications of the things that you learned about while playing. So play is something that matters not just for risk analysis, but it's important for data science generally, which is a skill that is needed across every single business. I really want to see the general workforce all around the world develop the ability to use quantitative risk techniques, not just for cybersecurity risk analysis scenarios, but for all kinds of general purpose operational risk scenarios, because it leads to a better conversation, a higher quality decision. Play and experimentation is absolutely crucial to getting adoption of these techniques, grassroots adoption. So we can think about governance, risk, and compliance. And when I think about the governance part of governance, risk, and compliance of GRC, I get really interested in how the cognitive ability of groups changes over time and how those groups are able to take on harder and harder challenges. Over the course of recent history, there have been tools and levers that have really acted as brain multipliers, as cognitive multipliers, that work at the front lines, on the edges, without centralized permission, where people can actually experiment. So looking back over the last couple of decades of a change in software and in computing, a couple of categories of tools really stood out to me as enabling major jumps in productivity, completely leveling up the capabilities of the workforce. So those two categories are version control and spreadsheets. Both of those tools started out as things that specialists used, but rapidly they spread into general use. And as those things spread, for example, spreadsheets, there soon came a time in order to be a professional knowledge worker at any pay grade, you needed to know at least the basics of using a spreadsheet. And one of the amazing things about spreadsheets is how they usually don't depend on a server. I can pick up a spreadsheet that has a model, a financial model, a risk model, a budget, and riff on it. I can come up with variations. I can try things out, connecting back to play and experimentation. A similar story happened with version control for code. In particular, this really fit for distributed version control. I can't imagine meeting a developer or even a designer these days that doesn't know how to use version control. And it's even spreading into general administrative work. We have versioning in Dropbox and Google Docs on our spreadsheets. So the dates on this slide are slightly editorialized to when I think those tools started to become available in the mainstream, not when they were first available for early adopters. And notebooks in particular are not a brand new thing. So in 2015, GitHub announced support for rendering Jupyter notebooks. So you just put a notebook into GitHub and it gets rendered on the web for you automatically. So these things have been around for quite a while. The tools are not a replacement for the work that you do using the tools, but they're definitely an accelerator. They make it possible for so many more people to do those computations, to build the models, to remix the code, and to share the data. The other idea is about working together. So people who do a lot of work in spreadsheets and people who do a lot of work in code tend to have very strong feelings about their tools, in my experience. The people that I've worked with that generally use spreadsheets every day have been, by and large, a different cohort, a different group of people than the ones that read and write code every day. And they have some different work patterns and preferences, even if the calculations that they're actually running are similar. So one thing that I was really excited about is over the last year, I worked with a product development team at a global bank, helping them set up a security program that included some quantitative risk analysis. And after we introduced notebooks, the feeling, the perception totally changed on the team from quantitative analysis is way too hard, it'll slow us down, to this is pretty cool. And then rapidly after that, hey, look, I did some additional analysis on some new scenarios. What do you think? So the team not only did analysis of some fair risk scenarios, but they also did some general business reporting on service level objectives using notebooks, and had a really good experience. So I want to break down these tools and help you understand notebooks and how similar they are to tools that you're already familiar with, like spreadsheets. So what is a spreadsheet. There's a lot of fancy features in there, but if you really, really step back and look at the core capabilities of a spreadsheet, it's basically two things. You have a grid, and you can see that on the screen there. There's rows and columns, and using those row IDs and column IDs, A1 and A2, you have a way to refer to a data value by a name or by an address. A1 is the address, and there's the number 5. You also have a way to call a function, and that function could do something simple, it could do something complicated, but you can call a function and you can give it data as parameters, including you can pass those by their address. So we can call the max function and give it A1 and A2, and we get the result of the computation that that function performed. And with that, you can do an incredible amount. So that doesn't look too hard. Equals max, you pass A1 and A2. What would it look like if we were to do the same thing in Python code and in R code? And I was definitely pleasantly surprised to see how simple both of these can be reduced as well. They have the same capabilities, a way to refer to a data value by name and address, and a way to call a function and give it data as parameters. So the first example there is in Python. Rather than having a graphical chart, we have lines of text, but we're still doing the same thing. A1, we're setting to 5. A2, we're setting to 10. And then we're calling the max function and giving it the data from A1 and A2. And this will return the result of that function, whatever the function computes. Exactly the same thing in R. Now instead of an equal sign, it's using left arrow, but the function call looks exactly the same. And very, very quickly, you can see how easy it is to move from the way you do a computation in a spreadsheet to the way you do a computation in Python code or R code. This is very, very easy to follow just after this 2-minute introduction. So that pattern works whether the function that you're calling is simply taking the max of 2 numbers or whether you're doing something much more sophisticated inside the function like calculating a beta-pert distribution. So what's actually inside a notebook? Well, both code and spreadsheets that I showed have a problem. And that problem is that it's really difficult to include narrative text, explanations of what's going on. And so when we're working with analysis of risk scenarios, having that narrative text describing the assumptions going into the scenario, the details of the scenario, it's absolutely crucial if we want to reach a shared understanding. You can't do peer review, like clarify the assumptions, refine the details of the scenario, update the information in the scenario. Any of those things require that you can clearly understand the story that you're trying to capture in the numbers. So spreadsheets are really, really shareable and remixable, but they're not very traceable. There was an interesting story. I talked with someone who worked in quality control at a large drug company, and they told me how much work they had to go through every time they were going through calibrating a production run of actually opening up spreadsheets and manually inspecting the formulas to make sure that nothing had accidentally been changed. So traceability is really weak on spreadsheets. Code is extremely traceable through version control, right? But it's not that great at being remixable and shareable, especially with people in different teams or job types. So developers might say, what are you talking about? I can share code all the time. But shareable with people in different job types, shareable with people outside your team, code is pretty poor at that. Usually only the authors can read and understand the code. So what notebooks are, what's in a notebook, is this really interesting hybrid that's good at all 3 of those things. It's like a better narrative code. So the big idea is a document that has chunks of text, it has chunks of code or formulas, and you can mix and match those in a very readable way. And it's designed from the beginning that you can publish the results of that notebook, and you can save it in version control. You can publish it on the web, and you can take chunks of one notebook and import them into another notebook. So it's very, very remixable. that whole concept of publication sharing is baked in right from the start. So there's two major flavors of notebooks. One is from RStudio, and that's called R Markdown. And one is from the Jupyter project called Jupyter Notebooks. So now I want to show you some demos. So this is where it'll be really handy if you want to open these up locally, and you don't have to just watch the video, but you can go to talks.kindlyops.com and look for the notebooks talk, and you can jump to this slide and have all these links here. So there is some examples from Jake Vanderplas using Python. He actually wrote an entire book on data science using Jupyter Notebooks. And if I click this open in Colab, here it is. Here's the notebook. And you can see that this is very, very readable. There's text and there's code. As I click on each of these little code things, it's going to execute that code and show me the results of the computation. And so as I'm reading through this scenario, I can see exactly what's happening in each of these. And so we're going to go through and recompute this graph that was shown. And you can see exactly what's going on. The text explains it. You can see a little line of code at a time. And just to show you how easy this is, we're going to change this. And so right there, I'm not going to dive into the details of what's going on in this graph, but you can see that the location is set to upper left, and we're just going to change that to upper right, and then recompute this section. So when I hit play, you can see that the legend has moved location in the graph. That's exactly how easy it is to experiment with things in these notebooks. So there's some other good examples. Will Meyer, who I've worked with on some of these, did a really nice example showing how to do quant risk analysis in Python. So there's a notebook available there. And then I've done one with fair calculations in R. And you notice that all of these are published on websites, on GitHub, and this one's also published to another site called RPubs. But the idea of sharing is in all of these. So you can pick up any of these example calculations and immediately start tweaking them and editing them and be up and running very, very quickly. So just how far can you go with notebooks? Well, you can go pretty far. So there's a couple of interesting projects that really shine for showing how large-scale adoption of notebooks for performing all kinds of data science in a big team can go. So one is the Airbnb Knowledge Repository project. They were going for these key qualities of reproducibility, consumability, discoverability, learning, quality. And so there's some articles linked here that talk about building the knowledge repository, all built around Jupyter Notebooks. Really, really cool story there at Airbnb. Netflix has also been making extensive use of notebooks throughout their business. So there's a wonderful post about scheduling notebooks. And they do a couple of interesting things there. They're using notebooks not only as an interactive UI, and that's kind of what we showed in the demo there, but also as the unifying foundation of their workflow scheduler. So once an analyst or a scientist works out and settles on the computations in a particular notebook, those get checked into version control. They go into the scheduling pipeline and they actually get executed for performing large-scale industrial computation. So Netflix has 150,000 jobs executing in notebooks per day. Really, really exciting. When we talk about scalability, it's interesting to look at really big projects, but it's always important to remember, can one person get started? Can one person try this out? So the cool thing about notebooks is they scale down as well. Can I use a notebook on my phone and experiment with it? Absolutely. So there is an iOS client, a little application called Juno, And you can edit your Jupyter Notebook from your iPad. It connects to Azure Cloud Notebooks, or if you're running a private CoCalc server or a Binder server, you can connect right from the app on your iPad or iPhone. There are also support for notebooks from all the major cloud providers. So AWS has SageMaker, Azure calls it Notebooks, and Google calls it Colab. I don't know why SageMaker and Colab are such confusing names. Azure Cloud, at least you know where to find the notebooks. They're called notebooks. And if you want to run stuff privately on-premise, the Binder project and the Jupyter Server project are both open source and very, very highly functional. So the recap is encouraging curiosity and specifically working on giving everyone in your team new capabilities is really, really good for productivity and for analysis. I think notebooks are fantastic. They really, really take the strong points of code and the strong points of spreadsheets and put them together in a way that's shareable, traceable, and remixable. So the call to action is still the same. If you're building products that do data analysis, that do any kind of quant analysis, please make those products export notebooks. Don't hold the data prisoner. If you found this interesting or if you have questions, please feel free to leave comments below. Email me, elliot@kindlyops.com. I'm happy to hear from anybody who's trying to pick up and use these techniques in your team. And I love meeting people and sharing this stuff, so thanks for watching.